and welcome to Not All Fire. I'm Jude Evans, and this week I have the absolute honour to have my international guest, Brent Brooks, who is the Assistant Deputy Chief of Training, Hazmat and Logistics for Frederickson Fire in New Brunswick, but was previously 31 years Toronto Fire's high-rise specialist. Welcome, Brent.
Thank you. Thank you.
Joe is, I think Joe must be coming back. He must be on his way back from Maryland because we're recording this on Sunday because time zones, and it was easier to record for me on a Sunday afternoon and for Brent on a Sunday morning. But I think Joe must be back in the UK because he's got a training course week next week with his for his company on his level 5 fire engineering course. So yes, Joe will be coming back soon. He will finally start to get himself less busy with the wildfire research and some of the presentations that he's been doing this summer. But no, welcome, Brent. So I've given you a brief introduction. Brent and I first met at one of the Tall Buildings conferences probably 4 or 5 years ago, I think, and meet up at conferences every now and again. I am in awe of this young man. So as I said to all the previous guests that we've had for the last few weeks, if you would please just tell us who you are, what you do, and how you got to where you are, that would be really, really cool.
Sure. But yeah, Brent Brooks. I actually run a website, highrisefirefighting.com. It's nonprofit, but what I do is I just try to work with engineers, designers, and architects and give them the end user experience or the firefighter's perspective. And I find that's where we're kind of struggling a bit is that aspect of firefighter safety, and that's the firefighters end user experience. But I never really connect the dots until later on in my career. I'm a firefighter, I'm training, I'm going to fires. And then going to these fires, you start encountering problems with door control and ventilation and improper water supply and nozzles and hoses. And this became repetitive. And then I started to research, I started to study, I started to, travel the world, look at historic fires, what went right, what went wrong, connect the dots. And now, I guess just like you, it's kind of turned into a hobby. It's exciting. I get to meet new people. And that's where I'm at.
Oh, I suppose it's really interesting because obviously us as fire engineers, we always design buildings for the occupants and for the residents. And although we have to give consideration to firefighters and firefighting techniques, B5 in our approved documents, which gives us kind of prescriptive guidance, or we can look at things like that. You're right in the fact that a lot of people, sometimes it's an afterthought. So because we're more concerned about life safety, we have to make sure that the people who live there or the people who work in these buildings, and some of these buildings, I know we were talking briefly just before we started recording. I stayed in Toronto. First time I stayed in Toronto, I stayed in a building on the 37th floor, and I've never stayed anywhere that tall. And it was quite freaky. It was quite, because it was so tall, and I mean the buildings surrounding us in that the modern harbour part of Toronto, they're all super massive. Did you say there's one that's 120 stories, 105 stories?
Yeah. They're going to 105. And the big thing is when you start looking at these super tall buildings, it's over that 300-meter mark. And I think Toronto will eventually have 10. So it's certainly a big city. I think 3,200 high-rise buildings plus those super talls. I think we got 3, but I think the projection is to have 10 very, very shortly. So we're going vertical. We're starting to reach the sky, and that's where now we really have to work with firefighters, the end users, engineers, designers, architects, is come up with these strategies, because these are new things to us, new things in the world. What problems are we going to encounter? And if we can predict and forecast, potential hazards, we can come up with these different strategies. So, how do we get water to those heights? How do we evacuate people from those heights? These are all things that, we have to consider. And I just hope I can give you that firefighter's perspective on it.
Yeah, no, that's really cool. I know that I went to a presentation about the Shard in the UK when they were designing it, and they were talking about between the different occupancies. So you've got shops on the ground floor, and then you've got offices above it, and then you've got residential, and then you've got restaurants at the top. And between each of the different occupancies, they had a floor that was completely empty. That was almost like a service floor. And I was like, that'd be a really good place to have additional firefighter kit. Just so you didn't, so you wouldn't then have to necessarily bring firefighting equipment up from the different levels or up from the floors. They've got evacuation lifts and they've got these super fast firefighting lifts and they've all got the firefighting shafts. But it's about getting the kit to site as quickly as you possibly can.
It is. And we've always had this I guess theories and scenarios on how it could operate and other parts of the world do have those area refuge floors. They'll have water, they'll have seating, they'll have people, they could get people with disabilities in there, and then prepare for that next stage of rescue or shelter in place. But we got to gather all that information and come up with a plan, based on your fire department. When I started my career in the fire service, we obviously had bunker gear, but before my time, all they had were patch coats, so your legs were exposed, and then bunker gear became better and better and better, and then over my career. They realized firefighters were getting cancers, so they had to design a gear for particular protection, which is great. Now we have better gear with particular protection that protects us from cancer. But the downside of that is like wearing a plastic bag. So now we still have to do those same exercises. We're going deeper, farther, and higher in these buildings. Well, now we're exhausted regardless, but now we're exhausted with heat exhaustion, and that's very, very hard to recover from. So no matter how physically fit you are, I give the example of the game of hockey. So the game of hockey, hockey players are wearing PPE, protective equipment, and they can go hard for 2 minutes, come off the ice for 2 minutes, and all that heat is allowed to dissipate. Whereas firefighters, we go hard for 2 minutes. Well, we can't go back and sit and let that heat dissipate. It's a giant oven. So how do we design bunker gear and equipment for today's buildings to allow us to, have those longer working times? That's $1 million question right there.
We've seen a lot of that obviously in all the wildfires that we've been having as well around the world, not just in, I mean, Canada and America, the US, over here in the UK, Greece, Spain, France. We're seeing firefighters, and that's harder because you're outside as well. And if you're the temperature around you, I mean, it's we actually had this might not be relevant to you in New Brunswick, but it actually rained here this morning, which for the UK is probably the first time we've seen rain in about 6 weeks.
Oh,
Um,
wow.
it didn't last very long, but it was like, oh my goodness, it's raining. But it's the coolest it's been for days and days and days. It's probably only early 20s rather than sort of like the mid 30s that we've been seeing. But if you're outside and you're tackling a fire and it's 35 degrees and you still have to wear your protective clothing and you can't cool down. All I've seen is just photographs of firefighters being doused in water, going back to red tenders and being absolutely doused in water to try and cool their core body temperature down, because it's horrible. Heat exhaustion is such a kind of an unthought about thing. So whether you're in a building and you've got heat exhaustion because you've had to run up God knows how many stairs, or if some of the lifts aren't working, or if you haven't got the right kinds of lifts, then to carry kit up. I remember you gave one of the presentations when you talked about the amount of equipment that your teams would carry up and take with them. And I was like, I don't think I could lift that. Even when I was at my fittest,
Yeah, there you go.
which
Yeah.
is some years ago, I don't think I'd be able to. I don't think I'd be able to carry that, because that's a huge amount of kit that your guys would be traveling around.
It is, and that brings us back to those building systems. We are, heavily reliant on the building systems to be functioning properly, because we are human. We have age and physical fitness to contend with, and even if we do get there, how good are we going to be able to fight a fire when we're mentally and physically, beat up just from traveling from point A to point B. So
Yeah.
yeah, the designs, smoke control, containment, early detection, it's really the big picture that we have to look at. And if we look at that big picture, and I'm going to go way back to 1991, 3 firefighters were killed at the Meridian Plaza fire way back in 1991. Now, the NFPA 14 changed after that in 1993. So, after the investigations, after all the information was shared, we learned a lot from that fire that happened in 1991. But building, engineers, designers, and architects had made these beautiful buildings, but the information either wasn't shared or was shared in a form that firefighters didn't understand it, or the delay in us understanding and having to purchase equipment, it just didn't connect. So back in 1991, firefighters didn't know that they were using undersized hose lines. They needed 100 psi. They're using fog nozzles. Basically, the hose and nozzle package wasn't compatible to what the building was using. Fast
Oh.
forward now we know we've been able to make that disconnect, and now we know what hose and nozzle package we should be using for standpipe equipped buildings, and that's huge.
Mm.
Fast forward now to 2026, and you would appreciate this being an engineer. Do you guys have those new doors now that have I call them piano hinges? So it's a hinge that runs the top to the bottom of the door.
Yeah.
It's for smoke control.
Yeah,
Well,
I
they're
have
great,
seen
aren't
them.
they?
I have seen them. Yeah, yeah, yeah. Because it's a full seal the whole length of the whole length of the door.
Right. So from a design perspective and a smoke control perspective, it's excellent. It's something we have to do. But now when you put yourself in the firefighter's perspective, well, we have these 2-inch spring clamps to keep the doors open. Well, they can no longer be used on the hinge side. Or we have these other
Oh.
door chocks that would hang on the hinges. Well, now
Yeah,
those are
yeah,
gone. So now we have to rely on a traditional hinge or door wedge that goes underneath the door, and we know the problems with that. So you're going to encounter that at a fire. Oh my gosh, we couldn't wedge the door. We were struggling with the automatic door closure. Why?
yeah.
Well, because they got these new hinges. So we don't
We've
recognize
solved
that.
one problem.
Yeah,
we've
and then you
we've
created
created
another.
another problem. No. Oh no. How funny is that?
So as an
You're
end user,
yeah.
we got to share those problems. Not that anyone's at fault. It's just how we make changes, right?
Yeah. Because you're right, and that's exactly something somebody will go, oh, I've got a great idea, let's do it this way. And then all of a sudden we come along or somebody else comes along and goes, oh no, well that's affected how we're going to do this. We have this, it's not quite the same, but one of my clients has a theatre and they had a finger trapping in the doors with some kids because obviously doors guys, and they got the fingers caught. Whether they weren't being supervised or they're big heavy fire doors. And so the decision was made to put the protections in. Like we have in schools, you have these protectors so you can't trap your fingers, the finger guards. And I've come along and gone, well, I can't now check the hinges in your fire door because you've got door guards. And it's kind of like you guys can't then use your equipment because you've got this plastic trim to stop people trapping their fingers, but we might need it to check the fire door is suitable. You guys might need it to hold the fire door open so that you can fight the fire. So there's always something that I do regularly like to say, fire with bad guys, fire safety. We're always against this, whether it's accessibility or we're always the bad guys. But you're right. Sometimes it's thinking about how the equipment that we're all designing is going to be used, and it's going to factor into any kind of building.
It's tough. Even if we look at, obviously I'm talking high rise. That's my passion. But people, sometimes kids would fall out of windows, or suicide prevention windows. They would build them. Well, we didn't know about. So now we're trying to clear smoke, and we only get a window open 2 inches.
Oh
So
yeah,
now we're like, oh my gosh,
yeah.
what do we do? Well, then we break the window. Well, what does that do? Well, now I create fallen debris, which can fall to people below, which is obviously a huge hazard. It can cut our hose lines. So
Yeah.
now we, because of these fires, now okay, now we have another problem that we have to contend with. And not that it's right, because it's preventing, people from falling out of windows, suicide prevention. There's a
Mhm.
huge list of stuff. But now when there's a fire, how do we work within that system? And then that's what excites me is trying to figure these things
Yeah,
out.
come up with the solutions. You're right, because when I mean, I have been working this morning, and I've just been writing. I've just been reviewing some documents for a new care home that's going to be built, and I'm going through and I'm looking at the drawings and I'm seeing how the different things comply for the residents and how everybody's going to get. But you're right. You've got to sit. Sometimes you've got to sit there and you think, how is everything that we are deciding today going to affect the building actually when it's in use?
Yeah.
Because it's not just building a prescriptive building and designing a prescriptive building that will be compliant with the building regulations or whichever codes that we're using, but also that can then be used by everybody, including in an emergency.
Yeah. Yeah. And everyone has to be included. People with disabilities, people like think, okay, and when I mean people with disabilities, like I could, be in a car accident and break my leg one day and I live on an upper floor. Well, now, I'm going to be have difficult evacuating, for the
Yeah,
next
yeah,
6 months.
yeah,
So
yeah.
it's all these things that we have to consider, which makes it exciting because I know I will never ever stop thinking because everything's always changing. New things are coming out. Here's an example, only because we're talking about engineering stuff. Positive pressure stairwells. I think it's
Yeah.
brilliant. I mean, it's protecting firefighters who are ascending. It's protecting people that are evacuating. I mean, it's the best thing. But here's an example that happened in Toronto. And I would have done the exact same thing. So I have to put my perspective in that of the occupant. So I bring my e-scooter into my unit. I
Uh-oh.
plug it, I plug it by the front door because it just makes
That's what you
sense.
do.
I'm not
Yeah.
putting it in my living room. I'm not putting it in my kitchen. I'm not putting it in my bedroom. Front door is ideal. So now it catches fire, but it's just on the start of that runaway phase. So it's got this white
Mm.
smoke. So what do? Well, you'd naturally
Open the
want to
door.
take it out
Pick it
into the
out. Yeah,
hallway.
yeah,
So you take it out into the hallway, and then you start seeing the effects of this smoke. Again, I'm putting myself in the perspective of the occupant, and like, oh my gosh, I got all these units, all these doors on this. I know where to put it. Let's put it in the stairwell. What burns in the stairwell, right? It's concrete. It's protected. So this e-scooter gets moved to the stairwell. It seems that everything's been alleviated. Obviously, alarms have gone off. The fire department's responding. So we get there and this is a big, 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 big building. And we look at the alarms, like, hey, alarms on the 27th floor. We're going to go 2 floors below. We're going to walk up the stairs. Again, the building is functioning properly. The stairwells are pressurized. However, they're pressurized with a lithium ion scooter on a runaway now. So the tires are burning, the plastic's burning.
yeah, yeah.
We go 2 floors below and we're going to take the stairs. Well, you open the stairwell door, which is positive pressure, and black smoke comes billowing out into the hallway. So we close the door. Oh my goodness, we're on the fire floor. Good thing we went 2 floors below. Let's go 2 floors below again. Well, we do
Wow.
that. We open that door and black smoke comes out. Well, now we're confused. And now we're getting multiple alarms throughout this building. So
Because it's
we
spreading up and down.
but we're thinking room and contents. We're thinking which unit is causing the effects of the smoke. And then we're thinking, okay, maybe it's a mattress on fire in a hallway. So, but where we were when we were doing this troubleshooting thing, we realized, okay, one stairwell is crystal clear. So we know we can use that stairwell. We need to find where the fire's originating from, but we can't now because it's gone from the 27th floor, multiple alarms, up to the 47th floor.
Oh my God.
So to make a long story short, going on air, using our thermal imaging camera, we are able to find it, but now we're unable to extinguish it because it has to release its energy, which it
Yeah.
does. And now it's a smoke event, not a fire event. So do we shelter in place? Do you evacuate?
Oh my
All these
goodness.
things come into play. And all of that happens within the first 18 minutes.
Wow.
It's a big deal. So yeah, like so now we have the new next problem in high-rise firefighting.
Yeah.
Let's deal with a positive pressure stairwell with really an unextinguishable fire in it. It's just something more to think about.
Yeah. That's really interesting as well because of course, again, we design flat blocks and tower blocks and residential buildings like this. We design them so we expect the fire to be in a unit. We expect it to be in a flat. We don't expect it generally to be in a common area. We don't expect it to be in a stairwell because all of these areas are sterile. And we're getting better at having sterile areas in buildings like this. But when you come across, it's always that what if, isn't it? It's when you come across something that is unexpected that you have not designed the building for. The building will still operate in the same way because the building will protect it. You've got your 60-minute protected shaft, your protected stairwell. So the building will operate in a way that protects the people in the rest of the building, unless they want to leave or secondary staircases. But you're right. How do you tackle a fire like that? How do you go about solving that kind of problem? And you're right. I mean, again, lithium-ion powered equipment is becoming the next big thing. I mean, it's here. It's not becoming. It has become the next big thing. It's a massive issue here in the UK, across Europe, across Canada and the US. I know. So it's a really big challenge as to what to do. I mean, I think I had one of my clients rang me the other day and went, "Do you know of any fire-resistant bags for laptops and computers and phones if anybody has an issue with a lithium ion runaway in one of these?" And I was just like, do we do those now? I mean, it's suddenly we've we've invented something that we haven't thought about how we're going to deal with it.
Yeah, they have them on planes. They have the oven mitts and they have those
Yeah.
zippered bags. And that, super scary, obviously, flying high above us. But I find technology is always ahead of us. So,
Yeah.
technology is ahead of us. You start seeing the effects. Now you have to, look at design, how to protect the building, how to protect the people. And then I'm the end user. I'm going to get exposed to, hey, we can't extinguish these fires, or like
Yeah.
those scenarios I told you about. So this is what's exciting. There will really never be a solution. There's always something new coming down.
Yeah.
That's going to shock us. I mean, well, you're in the UK, I'm in Canada right now. It's sharing this information, connecting the dots. What have you experienced? What have I experienced? Because we will never live long enough to make all these mistakes. We need to share this information in order to get a better understanding. So maybe if you build that piano hinge door, okay, how will we secure it in the open position for firefighters? Once you know our perspective, or okay, those windows, how are we going to clear smoke? Or if we do get a fire in a positive pressured stairwell, how are we going to deal with it? Or in the underground. And I love this now because we can sit there and we can debate and we can talk about it. You'll have a committee meeting in the UK and discuss it. I'll have a committee meeting here in Canada, and one of us, with these great-minded people, will have a good theory, anyways, that we can try out.
Mhm. It is. It is. I think when we're looking at, I've talked, we talked about it on the podcast before about how there's different scenarios for um, different organizations, or not organizations is the wrong word. What do I mean? I mean different. Oh, come on, brain. I haven't had enough coffee yet today. Where you've got different, I suppose, criteria, perhaps. So we were talking to Emily Harbottle a couple of weeks ago, who presented at the Tall Buildings Conference about understanding risk. She came from military aircraft investigation and moved it across into high-rise investigation about understanding risk in different bits and pieces. And whilst we were talking, she was saying about, I always turn around and say, why have we never learned from the fact that we've had, in the last 10 years, we've had so many different fires in nightclubs that have involved combustible insulation inside buildings where we've used fireworks. And we've seen them all across the world, from the Station nightclub all the way down to in the UK, in across Europe, and out in Goa and places like that. And we were talking about how it's interesting that if we have an aviation accident, then it spreads to all different aviation organisations, and so we've got this kind of international understanding of risk within aviation. And if your organisation or your airline doesn't comply with that, then we won't let you land in our countries, that kind of thing. And it's the same with shipping. And we talked about the story about how irons on cruise ships now cut off after 10 minutes because of the massive fire that we had on that cruise liner 20, 30 years ago, which took out the front half of the ship because it was just an iron that overheated. And we don't seem to have the same kind of standard approach within different countries for fire safety within buildings, because I suppose they're only our buildings in our countries. If it's international and you're traveling internationally, like aircraft and ships, then you do, or even cars to a certain degree, because you sell them around different countries. So they have to meet everybody's standards. Whereas if we build in this country, we've obviously got the NFPA codes for the North American countries, and you can use them around the world. And then we've got the British standards and building regulations for the UK, and then you've got the different building regulations and DIN for Germany and the different European standards there. And then Australasia and New Zealand and Australia and everywhere around the world, we've got all these different kind of criteria of how we build, but it's not kind of standardized. And without these kind of conversations that we have, we can't learn from each other.
Yeah,
that's the whole point I was trying to make then badly.
Oh, I totally get it. And I can tell you that, every time that I've been on a cruise ship, I have an evacuation thing that I have to participate in, and I have to go to the muster point. They're going to, lower these, put life jackets are going to lower. And this is where I'm going in the event of a fire. And then every single time I travel on a plane, it's the same message for that exact aircraft that I'm on. We have 2 exits at the front, 1 at the back, whatever the case may be. It's repetitive, it's ongoing. But when we get a high-rise building, there's none of that. They're like, here's a pamphlet, read it. And then they expect you to understand it. I think when you move into a building, you should do that walkthrough. If there's a fire, this is how the building's going to behave. And cities are trying to do this generic answer, shelter in place, evacuate, horizontal evacuation, dump half the building, don't have, they have all these different theories, but the building and its protection system dictates the strategy that you have to use. So there should be that, welcome to 123 Main Street. We have a 30-story building. In the event of a fire, here's your exits, and let's walk them. Let's see what you're actually gonna encounter, because more people are dying in high-rise buildings than they are planes and boats. So education is huge. Is
Yeah,
huge.
That's a really good point, actually, for resident engagement. We talk about this all the time because we move, especially in social housing, is you'll move somebody into a block of flats or a tower block or a tall building, and you'll be like, okay, here's your flat. Here's your information pack. Read that. Any questions, drop us an email. And it's like, you're right, there's no kind of, this is your house, this is your building, this is your flat, this is how this works, this is how the doors work, this is... Some organizations will do this, but this is your front door, this is your flat entrance door, this is a 30-minute fire door because of this is this because of this has a door closer because of this. These lifts are for the fire service, don't damage them because the fire service might need to come up and rescue you. This is the smoke extraction, which is again for your evacuation, but also, so we don't do that kind of whole, you're right, it's like we don't have we have the cheat sheet that you get on an aircraft, but we don't have the whole spiel that we have trained people to deliver to occupants when they move into a building.
And it has to be specifically designed for that building. So the building I'm in now, one of the stairwells is pressurized, the other stairwell is not. So if you
Ah.
think, oh, I'm just gonna go to the stairwell, you might be in the wrong stairwell if there's a fire on a lower floor,
Yeah.
but you might be in the right stairwell if the fire is on an upper floor. So
Mm.
these scenarios, I know that what ifs have to be, taken into that strategy. Look at schools. Our kids when they go to school, everyone musters, everyone gets in line, we leave, we close the door behind us, and we meet at a muster
Shut the
point.
window. You do the thing. Yeah, yeah,
Yeah.
yeah.
But when it comes to a high rise, it's just it's a free for all. You go to the elevators. Oh my gosh, the elevators aren't working, and then the fire doors or curtains come down. There's a
Mm.
fire. It's smoke. You smell it. It's exciting. And now that particular building has changed. The doors are closing. What's happening? Now you're really excited. Where do I go next? And then that's when you start to panic. Panic is very contagious. The more people panic, the more excitement,
Mm.
and now you're into a problem. And then the firefighters come, and now we're introduced into that problem. We got to rapidly troubleshoot it. Yeah, it's a tough thing, but I think education is key for your exact building that you're in.
Oh, I think that's a really, really good point. Because the whole thing is you guys don't want to turn up to a building and or have loads of people decanting all over the place, have all sorts of doors. You don't know where the fire is, you don't know what's going on. There's no cohesion about what is happening because everybody's just started to panic, so everybody's just left. So it might well be that it might have been a nice simple problem that had somebody at the first point stayed calm, it wouldn't have reacted. Human behavior is a really, really interesting thing, though. It factors in so heavily with, and again, sometimes we don't think about it when we're just designing buildings. You don't sit there and you go, the human behavioral factors of evacuation of we were doing a thing, one of the team and I were talking, Chris, we were talking about if you've got a building that's got quite a big floor plan, if you look at how people react to alarms and how they travel, you're never going to get the point where everybody's going to turn up at the top of the stairs at the same time because people react differently and they respond differently and they pick up their coat and their keys and they travel at different speeds. So you're always going to get this sort of flow of people to an exit, even in an alarm where you practice all the time, because people behave differently to alarms and we react differently to an emergency.
Mhm. Here's another example about design. So the fire department connections. So that's a connection that we hook up to either to supply the standpipe system or supply the sprinkler system. And walking through in most cities globally, when I go there, like they're beautiful. Some are chrome, some are brass. They're decorative. They're in a good location in relation to where the fire truck's going to park and where they're going to
Hmm.
hook up their water supply. Everything looks great. But what I want people to envision is what do charged hose lines look like on that fire department connection? So I can tell you there's a lot of connections that when we hook our hose lines, and they're big, right? They're what they be 65 millimeter, so 2.5 inch hose line. When they're charged, they're rigid, they're not flexible, and they're heavy, but they're actually blocking emergency exit. So people can't get out and we
Oh,
can't get in. And
because they're heavy. Yeah, yeah.
huge. They're huge. And all you need is one, slow person to encounter that trip hazard or that hose line. And now you get that bottleneck happening behind. So we have to, look at the full setup or the hydrants on the opposite side of the street. So the hydrants on the opposite side of the street, well, now we're using 100 mil hose or larger to supply that hydrant. But now the aerials can't get into play to put their ladders up because
Because you
there's a
block the
big
road.
there's a big blocked road. So
Yeah.
actually, I'm writing a thing up now on um, when the hydrants are on the opposite side, how we can, start that setup of maximize the hydrant, prepare for that road closure, allow the apparatus
Mm.
to get into play and get their aerials up. Um, but
Oh
yeah,
gosh,
it's
especially for the
it's a
tall
big
buildings because your appliances have got to put their big feet out to make sure they're stable before they extend
yeah, the
up
outriggers.
huge high. Yeah, yeah.
And those aerial trucks are even smarter now. So if you don't have the outriggers perfectly deployed, you're not just going to get that height that you need, or the truck will just say, "Hey, if this isn't
Yeah, no.
safe, I'm
Yeah,
not
yeah,
doing
yeah.
it." and you just wasted
You'll topple.
time and resources.
That's interesting what you said actually about where, for us in the UK, it would be the location of the dry riser inlet where we're going to connect the hoses to from the tenders, because they're always by the doors. Literally, you have literally your main door to even a small block of flats, even it might only be a 3 or 4 story block of flats, you will have the door and then you'll have the riser inlets, and it will literally be within a foot, within sort of, I don't know, yeah, 500 mil of the actual building door. And you're right, if you've kinked it, then that's gonna absolutely get in everybody's way trying to get in or out.
Yeah, and
So,
when I was in the UK, well, I just saw you recently. I noticed that these beautiful design building, the fire department connections in a great location. But then if you look at where the truck's going to park and how those hoses are going to be laid to that fire department connection, there's a fence there. So
I
now they're gonna
know.
have, yeah, so they're gonna have to take that fence down, or there's a concrete jersey barrier that the hose has to come up and over. And it doesn't just fold to that jersey barrier. It's
It's
going to
gonna
be
be a
like
big
this.
kind of
So
curve,
now you're
yeah.
actually closing, well, in this case, you're closing the bike lane, closing the pedestrian lane to get that hose to that fire department connection. So I think it's just the bigger picture we need to look at when we design these buildings.
No, that's it. It is. It's such a good point. I've got literally probably 5 or 6 buildings. I'm just sort of scrolling through in my head, going, "Oh, that's probably too close. Oh, that's not going to work," because you're right. If you don't plan it, and if you haven't got the fire hydrant locations close to where for the standpipes where you're going to be, you're right. It's. I mean, the UK, we do tend to have an awful lot of fire hydrant and standpipe locations located in the road. So you're always going to have to close the road. Um, but yeah, it's it's a really interesting point. Really, really interesting key point.
And and
So
and, and what I've seen globally is so Singapore, and you wouldn't notice if you weren't in the fire industry and you're just a tourist, you're not going to notice it. And that's why I like it. But it's not offensive. It's just a beautiful thing that they've done there. But they've put these yellow markings where the aerial outriggers go, and they put these red markings where the engines part or the fire pumpers part.
oh, that's
So
cool.
so they've actually taken these things that I've talked about, put it into their not just the building design, but the city plan.
Oh
If you get a
wow,
fire in this building, the aerials park here, the pumpers park here, your water supply. So they've been able to make that connection, which is
that's so clever.
great, which is huge.
Yeah.
But there's one more thing you have to think about is you have this great idea, the plan's all laid out, it's going to work, we're going to get our water. But now when we start putting our aerial devices up, we got hydro lines to contend with. So now we can't set it up as designed. So I mean, I
Yeah.
can keep, it's just, yeah, it's that big picture. But at least now in the downtown cores, the hydro and lines have gone underground. But where I'm living
Mm,
right now, I know the one side of the building, we just can't set up our aerial devices because of those hydro lines. And that's
wow.
fine as long as I know that prior to getting a fire
In
in
that
this
building.
building. I have to come up
Yeah.
with other strategies.
I
So,
was talking to Joe a few months ago, and we were talking about California and about how everything is above ground because they can't put stuff underground because of earthquakes. And of course, that's that same kind of issue. If you can't put stuff underground because you're in an earthquake risk area, then and it has to be above ground, you do have to think about how those things are put together. But then I suppose if you're in an earthquake area, you're probably not going to build too many tall buildings.
well, look, I was just in Chile, and I mean it's
Oh, they've got loads of tall buildings.
huge seismic, and I'm in these buildings, and they're called dampers. Dampers we think are louvers that open and close, but these dampers are these giant weighted pendulums that move on the top of the building and stop building sway. And then I'm in the bowels of the building underneath it. I'm looking at these rubber dampers, and I was just like, this is so cool. And then we got into discussion, and their glass is different, right? So
Oh,
if they need to break glass, you're not doing it with, traditional methods that we use here in North America. So, um, depending, or look at Florida, they have hurricane-proof windows. So
yes.
we can't break glass. We can't do the
Wow.
conventional firefighting. So your region, your country, and we talk about seismic, we talk about hurricanes. That's why these plans that we design for occupants have to be specific to that building. Because guess what? We can't take the windows.
No.
They're just reinforced.
No, that is quite mad. I did see on Instagram a couple of days ago there was some construction workers were on the top of a tall building that they were building, and they've got the metal um uh the bracing, the metal bracing. They were pouring concrete around it, and an
Okay.
earthquake hit, and they all kind of grabbed hold of this bit, and this building was doing this, and they were all perfectly safe, but there must have been like 20 guys on top of it, and when you just sit there and you go, I don't
Uh,
want to live there. That gives me the fear.
I don't want to
So.
be here right now. Yeah.
Oh no, gosh. But you're right, because of course, yeah, where you have hurricanes, um, you're always going to have buildings that are strong, that have stronger construction. Where you have earthquakes, they're designed for earthquakes. So yeah, that's quite an interesting, it's quite an
Yeah.
interesting point. And you're right, it's all specific to the country that you live in.
Yeah, we're not, trying to fear monger, but our job is to come up with these, what if scenarios, and we need to predict and forecast, that next problem. So when we do get it, we'll be better for it. Well, for instance, here's another example. So a space pen, they need a pen that can be written in zero gravity, all sorts of conditions. So we were getting these pens in the fire service that we wanted to be able to write in the rain, which you can, but then we found that the pens were freezing. Make a long story short, they're $80 pens. It got really expensive. They still weren't working. And at the end of the day, someone came up and said, a pencil can work upside down, work in the rain, and doesn't freeze. So some of that
Yep.
technology is great, but sometimes you just got to go back to basics. And
Yeah, yeah,
that grease
absolutely.
pencil or pencil, yeah, works in all sorts of conditions. So
Absolutely. Nothing beats a crayon.
and that's beats a crayon. I love it. Yeah.
Oh,
So yeah,
um,
technology. It's
it's
fun and
interesting, isn't it?
exciting. We just got to figure out how to connect the dots when they build a place.
No, that's fair. That is fair. Do you think there's any up and coming challenges within our industry at the moment? I know everybody's talking about PV panels and everybody's talking about these massive big battery storage centers that we have, and obviously we're always going to have e-bikes and e-car, well, e-bikes, e-scooters, maybe e-car challenges. But
It
I
is, and
wanted,
I know in Toronto there was a thing where no more e-bikes in commercial buildings. You come up, they have to stay on the exterior. It was great. We thought we solved the problem. But now, because the price of the batteries, well, now they're taking the batteries off their bikes, putting it in their
oh, taking,
backpacks, bringing them inside the building. And now we have what we call like clandestine desk fire. We're going to a desk fire. We think it's a desk fire. We can put it out with a water can. Meanwhile, it's a fire lithium ion in a desk that can't be extinguished. So
oh,
we tried to solve a problem and it didn't. And then the other one was our subway, that fire in Toronto, the subway, no more, bikes in the subway. Well, that kind of locks the system down. So then they say, okay, no more bikes in the wintertime because salt's a problem,
yeah,
with that. So yeah, there's a lot of solutions or sorry, not solutions, problems that, we can predict. But when we come up with a solution, sometimes it makes things worse. But back to your question on energy storage, it is the reality.
mm,
We need energy and we need water to cool these systems. And I think if you look at buildings in Singapore, even in New York City, the One World Trade Center, it collects rainwater for the fountains for the September 11th monuments. So we know we can collect water from these high-rise buildings. We know we can collect energy. We know we can store it. We do have to continue that. We know we can design louvers to heat and cool these buildings. So we're getting really good at it. But when these systems fail, how do we fight fires? How do we protect smoke from getting through the building? That's where we work together, and we have to hash these things out. Today we have a thing called a rotor distributor. It does 500 GPM. So what's that? 2,000 liters per minute. It's a lot of water. It has no nozzle reaction. It was made 200 years ago. So back to that pencil theory, it's a nozzle that's 200 years old that we're using today to help protect exposures from catching fire during a lithium-ion event. So we set it, we forget it. That buys us time now until we can, come up with these different solutions. So energy storage, yeah, we have to figure that out. We need that technology. We have to figure out how we can live within that technology. And when that technology fails or becomes a problem, how we're going to protect exposures, protect occupants.
No, that's a really, really valid point. Really valid point. Thank you, Brent, for coming on our podcast. It's been absolutely lovely to see you again. Hopefully we'll get you back on at some point when Joe's here as well, because I'm sure he's got some technical questions to ask you about different firefighting techniques. So, but thank you everyone for listening. Thank you everyone for watching. Again, thank you, Brent. I'll hopefully come and see you in New Brunswick next year.
Please do.
So,
please do.
See what we're doing. So, we'll be back next week with another guest. Exciting. Thanks everyone for watching again. Bye.
Bye-bye.